YFQ-44A just changed everything. For years, air combat has been defined by speed, stealth, and the skill of the pilot inside the cockpit. But what happens when there is no cockpit at all? The first flight of the YFQ-44A wasn't just another test event on a quiet runway. It marked the beginning of a completely different era, one where artificial intelligence, autonomous coordination, and manned-unmanned teaming redefine how wars are fought in the sky. And this is not science fiction. This is happening now. The YFQ-44A is part of America's next-generation push toward collaborative combat aircraft, advanced autonomous jets designed to fly alongside crewed fighters like the F-35 and future sixth-generation platforms. But unlike traditional drones, this isn't remotely piloted in the conventional sense. It thinks. It adapts. It calculates in milliseconds. When the YFQ-44A lifted off for its first flight, it proved something critical. Autonomous combat aircraft are no longer experimental concepts. They are operational realities in development. And that changes the balance of power. For decades, air superiority relied on putting the best human pilot inside the most advanced jet. Training took years. Experience was priceless. Losses were devastating. But autonomous wingmen introduce a new formula. Instead of risking a human pilot in every forward strike, a crewed aircraft can command multiple AI-driven partners. These aircraft can scout ahead, carry extra weapons, jam enemy radar, or even act as decoys. Think about that. An F-35 or future sixth-generation fighter could control a small fleet of autonomous jets, each one performing high-risk tasks independently but coordinated as a single combat network. That's not evolution, that's transformation. The YFQ-44A's design reflects this shift. Clean lines, stealth shaping, internal weapons capacity, advanced sensors. Everything about it suggests survivability and integration, not just expendability. This isn't a disposable drone. It's a force multiplier. And that distinction matters. Military planners have long known that future conflicts will be data-driven. The side that processes information faster, shares targeting solutions quicker, and adapts in real time will dominate. The YFQ-44A is built for that environment. Its systems are designed to plug into a larger combat network, receiving data from satellites, ground stations, crewed aircraft, and other autonomous platforms. It doesn't operate alone. It operates as part of a digital ecosystem. Now imagine a contested airspace scenario. Enemy radar systems are scanning the skies. Surface-to-air missiles are on alert. Manned fighters approach the edge of engagement range. Instead of crossing that line themselves, they deploy autonomous partners forward. The YFQ-44A moves first. It maps threats, identifies emissions, relays targeting data back to the human commander. If necessary, it engages, all without putting a pilot at risk. That changes strategy at the highest level. Air forces can project power deeper, faster, and with more flexibility than ever before. Loss tolerance increases, operational options expand, and perhaps most importantly, decision speed accelerates. Because AI doesn't hesitate. Of course, autonomy in combat raises serious questions. Rules of engagement, human oversight, ethical frameworks. These discussions are ongoing. But what the first flight proved is simple. The technology is ready to move forward. Historically, revolutionary shifts in air combat have come in waves. The introduction of radar, the jet engine, stealth technology. Each one reshaped doctrine. Each one forced adversaries to adapt. The YFQ-44A represents another wave, autonomous integration, and competitors around the world are watching closely. China, Europe, and other major powers are developing similar manned-unmanned teaming systems. The race is no longer just about faster jets. It's about smarter networks. The first country to perfect seamless AI combat integration gains a decisive advantage. And that is why this first flight matters so much. Because once autonomous wingmen become reliable, scalable, and combat-proven, traditional force structures begin to shift. Squadron compositions change. Procurement strategies evolve. Training pipelines adapt. Air dominance becomes less about individual aircraft and more about integrated systems. The YFQ-44A is not replacing fighter pilots. It is amplifying them. It is extending their reach beyond physical limits. It is allowing one human to command multiple combat assets simultaneously. That is the real breakthrough. And we are still at the beginning. Future iterations will likely feature improved stealth coatings, enhanced sensor fusion, greater payload flexibility, and more advanced machine learning algorithms. Each upgrade tightening the integration between human decision-making and machine execution. So when we say the YFQ-44A first flight changed everything, it's not because one aircraft took off. It's because it confirmed a direction toward autonomous combat ecosystems, a direction toward distributed air power, a direction toward faster, smarter, more resilient dominance in the skies. The question is no longer if autonomous fighters will shape the future. The question is how quickly they will scale, and who will master them first. And in modern warfare, speed of adaptation decides everything. The YFQ-44A just took its first step. The world is watching what comes next.